All right, anyhow, so we are back now and dealing with clouds. And we talked about convection a little bit. Get off my arse here and walk around a little bit. We talked about convection a couple minutes ago. Told you that the idea that warm air expands, so it goes up into the atmosphere where it cools off, it contracts, then sinks back down to the earth. Therein lies basically 14 weeks worth of meteorology in the energy transfers that are going on there. It is mind-boggling. It is nuts stuff with math. We are going to, and again in the chapters in your book, they start to go into this. I don't even start to go into this. What I'm going to tell you guys is that when this happens up in the atmosphere, it can transport moisture up there and leave moisture up there. All right? And that moisture brought up into the atmosphere is what will go on to make your clouds. So we use convection not only to transfer the hot air up and the cold air down, but to move the water vapor up there that we're making clouds out of. Recall rain formation ideas. This too is telling me that I should have done the water cycle by now, which I haven't done. Sorry, again, out of swing out of things for a couple of years here. How can we, because I still want to give you that lecture. What I'll tell you is this, that when water at the surface, okay, gets turned into water vapor, when that warm air gets heated up by the sun at the surface, any water that's around there will get turned into water vapor, which is a gas. All right? It then can travel up with the warm air up into this atmosphere to the point where it gets cold. And we told you that the cold air then shrinks and returns to the surface. Well, the water vapor stays up there. But because it is cold, it turns back into its liquid phase. It turns back into water. Or if it's high enough, it can turn into ice crystals. Some clouds are formed of ice, as you'll see. So what happens then is that these cloud droplets, these water droplets, they accumulate over time. And as they get big enough, a cloud starts to form. Clouds are liquid or solid water, as I just mentioned, ice. They're not water vapor. That's one of the biggest things that we need, misconceptions. Folks coming in the door, they think clouds are water vapor. They're not. They're not gas. Right? Teeny tiny water droplets or teeny tiny ice crystals. And like I said, I promise you, you will still get water vapor. So convection is that water moving up, along with, I see my battery thing there, along with the water moving up into the atmosphere and leaving the water drops behind. All right. All right. Clouds are minuscule. I'm sorry. Yeah, cloud drops are minuscule compared to raindrops. You may have heard that it's a very flowery, poetic kind of thing, but that when it starts to rain, that the clouds are ripping themselves apart. And, well, essentially that is true. But, again, it's overly dramatic. The water drops inside of the cloud continue to grow until they're too heavy to be supported by the cloud's gravity. And they're more attracted to the Earth's gravity. at which point they plummet to their deaths at the surface of the earth. There, we got dramatic again. I'm never going to ask you on a test where that decimal needs to be for clouds or water, okay? Don't worry about silly little things like that. What's bigger, rain or cloud drops? Good. Who remembers these? Oh, good. We don't have to do it. No. Yeah, we've seen. They exactly. Some of them look familiar. And there's blends. Yeah, clouds are even the toughest. Well, and that's another one. Yeah, that's a thunderstorm cloud. That's a thunderhead. Yeah, that's everyone's favorite usually. Mare's tails. Yep, we'll talk about those. Those, I believe, are cirrus. Cumulus are the little puffy, happy clouds, the little cotton balls. Stratus are what we got out today, the low gray stuff. Although I can't see blue through there. So I'd say stratus is today, just sheets of gray. Mare tails are the super high ones. And that's another talk about difficult is elevation. All right. One of the things we were supposed to start in lab last week, the folks at home actually did start this last week, was your cloud journals. And I will never call issue with your judgment of whether something is middle or high elevation. It's damn near impossible to tell as far as I'm aware of. But some of these, like cirrus, they will tell you are high elevation clouds. So you just know those are way up there. But some of these others, boy, they could be altostratus, mesostratus, all over the place. So keep it simple. When we get to there again this Friday, we'll be introducing that on campus. It goes for like a month. You guys are just keeping track of pictures of clouds, and you can put them in a PowerPoint. Good time. It keeps you looking up. People actually, they go into saying, "Oh my God," but at the end they get a lot of, "Well, this was cool. I never looked up so much in my life." So hopefully you guys will fall into that category. So cirrus, stratus, cumulus, and nimbus. And yes, there's 43 varieties in between. And you'll learn and love most of them. But we're giving you, as I said, just an introduction. Cirrus, thin and wispy, mare's tails. That's what Grandpa used to say. These are high clouds, 20,000 plus feet. Irrelevant for this class, but just to let you know what high means. These are ice. And that's why they look so light and thin and wispy. They actually kind of look cold. I don't know if they remind me of frost or something, but. Now, even though these are ice clouds, you can still get them in summer. Okay, it's nothing to do with weather down here at the surface. It's always cold up there. Always cold up there. Just like you could go to the highest mountain on an island at the equator and still find snow. All right, elevation is totally different. Stratus. Stratus means layer itself, the word means. These are generally low, but as I said, you could have them at middle. So because they're lower clouds, they're going to be water, not ice. I would stay on the left side of the screen when thinking about stratus with these here. Because if you look over to the right, it almost looks like a bunch of the fluffy little happy clouds are clumping together. Oh no, is that how we get stratus? Maybe. But we don't want to confuse yourself. So we're looking at these straight lines of gray over on the left-hand side. Not where it's starting to break apart. There, your happy little fluffy cloud. I had fun even searching for these images on the web. Well, good. Then you will be a natural for the Cloud Lab But please do me a favor and try not to use your old ones. Get new ones. Okay. I will never know the difference, but we'd just like you to get new ones. I don't remember. I don't know where I was at sunset last night.
I was just leaving here, so I was on my car and I was like, oh, it's beautiful.
Nice. So these little puffy cotton balls can be deceiving. These nice day clouds can turn into very cool storm clouds. I like thunderstorms myself, so to me they're cool. Some people, they're the worst thing on the planet. So as I said, cumulus, that sounds like something I heard before, cumulonimbus. Well, we got to talk about nimbus first. I want to point out one. Oh, it's snowing now. I was going to say, boy, it's a lot brighter out there, but it's because the snow came back. I want to point out one difference here, that how we could tell, because you might look at these and say, well, this kind of looks all gray like the stratus. It does and it doesn't. See those extra dark spots? And this is the one way you could tell when rain's coming here. I don't often give you useful information. I'm aware of that. But this is one of them. When the bottom of a cloud gets super dark, it's become opaque. It's super dense down there. More than likely, it's going to start to fall out of there. In other words, it's going to start to precipitate. So when we see these nimbus clouds that, for all intents and purposes, were an hour ago cumulus clouds, or in a couple hours might just turn into stratus clouds, those dark spots in there tell you that those are rain bearers. All right, at the bottom, it's just there's no light coming through anymore. That's why the cloud looks white, because the sunlight hits it, it lights it up, literally from above. But it's so densely packed at the bottom, nothing's getting through anymore. And that's typically its breaking point. Sometimes it just doesn't make it to the earth. We've seen that. You know it's raining, but you're not feeling it. It's sometimes too dry in the atmosphere and it absorbs it. You could spend 2 weeks talking about what happens inside a cloud. Again, we just don't have the wherewithal in here to do that. But, so yeah, nimbus clouds. And it's those dark spots that tell you that the rain's a-coming. You guys have access to this image and a couple more when you're doing your cloud labs. I recommend you print them out. If you could find a nice color printer somewhere. I think for you folks on campus, I have some stacks printed out already. Folks at home, I can't really provide you with those. If nothing else, it reminds you how confusing it can get. We will get back to cumulonimbus. Precipitation. Snow, sleet, freezing rain, grapple, hail, rain. What time do we go to?
3:45.
So we have an hour 20. And I get the hardest by the time we get to midday and we're so far off of the primary hour that I just lose all semblance of doing math. So we start at 15 or we started at 20? We started at 2:20. So 3:20 is an hour.
And then we go to 45.
So it's not an hour 20 then.
2:20 to 3:45.
Hour 25. Yeah, all right, hour 25. All right, anywho. So snow, sleet, freezing rain, grapple, hail, and rain. Hopefully some of these sound familiar, and I'm assuming you have no idea what grapple is. Most people don't. That's good. We've got something to learn here at least. You'll also probably, some of you weatherheads know this already, will learn the difference between sleet and freezing rain. Or say, oh, I thought I knew the difference. I'm wrong. Some of you will be right.
Honestly, I thought hail was freezing in.
Oh, and hail too. Hail's different. Hail's yet something even different. Hail's only summer.
In summer?
Hail is only summer. Yep.
That's freezing in.
I got slides. I got slides. So you probably knew this. Snow is ice crystals linked together. That thing about no two snowflakes being alike is supposedly BS. I have to imagine there are some fairly common ones that occur with some frequency, but I did Google this a few places. You know, snow has a lot of variation in it. What do we call Eskimos nowadays? Northern indigenous peoples, I think. It's been said they have 100 words or 40 words for snow. Again, it's what you experience it. You have more description, more definition, more experience with it. We have around here, at least what I pay attention to, we've got big wet snowflakes and those tiny cold little extra cold crystally ones, right? If you ski, you might have some words for it. So on and so forth. There's packing snow, that's not packing snow. If you're a kid and you're still making snowball fights. But doesn't have to stop. But we are just going to leave it in here at snow. Cannot read that at all, can you? No, I'll change the font color. So what that says, for those of you that can't see it, what is sleet? Rain that freezes into ice pellets on the way to the ground. So in the air, on the way down, it's rain that freezes. Again, it's important to note that it freezes in the air, not on the ground. And this is a cold weather phenomena only. Because again, it has to freeze in the air on the way down. So not going to be happening when it's warm. So sleet is essentially ice that starts off as rain. But it's not arranged so prettily that we call it a snowflake. It's a pellet. No time to organize. You'll see by contrast in a moment what difference we've got here. Freezing rain, well, that's just rain, or we call it something else, right? Freezing rain is rain that hits and freezes almost immediately. This is the stuff that 9 times out of 10 makes you fall on your butt. All right, because, yeah, and I've been, knock on simulated wood, I've been lucky myself. This happens when you've got some temperature inversions going on, and it's really cold at the surface, all right? But it's still warm enough in the air that it's falling as rain. And this leaves that slick icing, literally, on the ground. Black ice, as my mother likes to call it. She's always, watch out for black ice. Watch out for black ice. So sleet, what we want to go to, ideally next, I would have went to, still not going there. Going to talk about grapple next. Grapple is soft hail. Huh. Well, what does that mean? Snow that crusted over with ice. And I wish I had a little bit more in here about the formation. It's not really something you see that often. But maybe for the rest of this winter, you'll pay attention to the stuff that's coming down when you happen to be caught outside when it is precipitating. And see if you can't find any of this extra crunchy snow. I'm guessing what happens is that you've got some malformed snowflakes, again, just a weird process going on in the cloud, and that they freeze even more on the way down. So it's like they start off as snow, then they melt a little bit, then they get cold again. So a couple temperature inversions in there. You'd think when I looked up grapple to find the picture, I would have put a little more definition in here for us. Ah. Is it sleet or grapple? The age-old question I know you guys have been struggling with for most of your lives. Grapple, snowflakes that collect supercooled water droplets on its surface. So again, it's going through another layer of something that's happening up there in the sky, and you're getting this ice coating on the outside. But sleet is ice through and through.
So grapple's like the snow that looks like salt.
Yeah, I kind of know what you're going for there. Yeah, I could agree to that, as long as it falls that way. You're not looking at something already laying there on the ground, though.
It falls like that?
It falls like that, yeah. No, because they'll poof when you squeeze them hard enough. Because they're not ice all the way through. That's the thing. It's like a candy coating on a snowball.
Okay. That's like the kind of snow that falls in like November.
Okay. I will not disagree with you. Because you got a picture in your head and I don't want to mess it up. So, I've not heard, that it's a fall phenomena versus a da-da-da-da. So I'm not going to say one way or the other. But yeah, if you got an image in your head, go with it. But you do see how sleet is definitely ice all through and through.
Yeah.
So hold on a minute here. Snow, sleet, freezing rain. All right. Yeah, we're right. I was thinking we were forgetting one, but we're not. And here's the last one here. So, hail, we told you only get in the summertime. That one does have a seasonality attached to it. Hail has to form inside of a thunderhead. One of those big anvil-shaped clouds. And I've actually finally, again, now that I'm starting to pay even more attention than I traditionally did, I've finally seen a few of these anvil shapes. Very hard, very rare, I would say, to find the actual, you'll see pictures in a moment, of the anvil-shaped thunderhead. And what happens is it needs to churn back and forth inside of these things. These thunderheads, they don't look it from the ground, but they're very tall. And often in that elevation, it's a function of where it starts and where it ends. The bottom of the cloud, you've got you've got water. The top of the cloud is up high enough that it's ice. And when these currents get started in the thunderhead, this is what jars up all this electricity. This is what jars up all that energy going in and out of these different phases of matter from liquid to solid to liquid to solid. These ice balls can get built up. And as you've seen, now I've never seen golf ball. Anybody see golf ball size? You always hear about golf ball size hail. What's the biggest you've ever seen? That's pretty big. I've never seen bigger than pea myself, pea size. But that's fairly common and smaller. But you always hear about golf ball size. And you can understand it cause a heck of a lot of damage then as such. But again, you only see those in the summer. So you could confuse hail with sleet. Right? You confuse it with sleet. What is rain? Save the easiest for last. And that's the middle bullet there. Not everyone knows or believes. Again, if your clouds are high enough, what falls as rain could oftentimes start as ice. Depends how high up the cloud is. I quickly summarized this earlier. You could just take another glance at it. I don't know that it bears a rewriting. Additionally, in the context of you will be seeing the water cycle within the next lecture or two. There is a really awesome, I grew up before Blue's Clues. My son actually grew up at the end of Blue's Clues, but it was still in reruns. And I'm guessing you guys grew up right around with Blue's Clues. I'm a Steve guy. I don't know about you. Always Steve. Steve to the end. And Steve's still awesome. He's still out there, by the way. He's putting out little videos here and there. He has actually an awesome groundhog one that I can't believe I haven't put into the Groundhog's Day folder. Called I Hog the Ground. It's him and a guy from Flaming Lips playing guitar, which is kind of an odd mix.
He was in a heavy metal band.
Yeah, he was a skater before Blue's Clues. But at any rate, so he could sing. You guys know that. Blue's Clues does in 3 minutes with one song, Steve and Blue and a water droplet. They give more understanding into the water cycle than I probably could in a 30-minute lecture. It's amazing. The episode's called Stormy Weather, and I used to have an isolated clip of it, but since I've been switching laptops and everything, it's evaporated. We'll just say that for the moment. But if I could track it down by Thursday, I will show you guys. And again, folks at home, I'm talking to some elementary education majors. And even at your first graders, they're going to say they're too old for Blue's Clues. But I highly recommend, if you find yourself in an early grades having to talk about water cycle, showing this little clip. And when I show it to you, you'll see why. It's amazing. Just how much science they could fit into a song that rhymes in 2 minutes. Mind-boggling. Good writers. Good writers. So it's all about phase changes. And those phase changes, we really undervalue them in here. And that's the difference between meteorology versus tackling this in a little bit of Earth science class. Those phase changes release energy, okay? And they store energy. And that's what really drives the weather, okay? Because otherwise, you need to have energy to move these transactions around to have all this stuff happen. Your thunderstorms wouldn't be thunderstorms without energy, and at the very least, it's all about energy transfer. You're going to see when you do the readings, and again, I encourage you to read, you're going to see about latent heat of evaporation, latent heat of condensation. That's what they're talking about. It's heavy stuff, and as I said, I've chosen to gloss over it because of that. But if you dig that stuff and you wonder about that stuff, that's where it's all at. Okay? And that transfer of energy around is what keeps everything going. And I really didn't have to stretch this out to 4 slides, but I found so many pretty pictures of raindrops that 5 slides. All right, we're going to stop there, and we'll pick up where we left off when next we meet again.